All right. Hello, everyone. Welcome to Serious Web Services, WCF, Web API, OData, and more. I hope you're ready to get serious, because this is a serious talk about web services. I assume you're here because you want to find out how can you navigate the world of all these .NET frameworks that are available to you for creating server-side logic. There are quite a few. Actually, when I was creating some of my slides, I was like, whoa, yeah, there are a few choices here. So most of what this talk is going to be about is providing you guidance on how you can choose the right tool for the right job. You want to create a web service? What should you use? So you want to create a serious web service. And I kind of broke apart the options that you have into these two camps. There's the ones that are branded with WCF and the ones that are branded with ASP.NET, although the branding is kind of funny in some of the situations. I'll give you some historical context on a couple of those. With WCF, well, there's WCF Classic. And by WCF Classic, I mean, the SOAP stack, what WCF was originally built for. WCF, when in its inception, was intended to unify all of the distributed application technologies that Microsoft had at the time, ASMX, remoting, COM+, MSMQ, and create a single unified service model, programming model that you could use to create services over any of those transports. And the way it did that was by using SOAP. So that's what WCF is. WCF Data Services is actually, give me a little holler if you're using this framework today. Who's using WCF? Classic WCF. Oh, yeah. Whoa. Okay. Lots of WCF folks in the crowd. Great. Nice to see you all. WCF Data Services is a framework where you want to create OData services. And OData services is a great and simple way where you have some data, often like sitting in a SQL database store, and you want to expose it using an open protocol, web-based protocol that you can then use to query and manipulate the data. So it's for building OData services. Who's using WCF Data Services? Who's in the crowd? Okay, a few. We got a few folks. Okay, cool. WCF, oh, by the way, the WCF and WCF Data Services, that's mostly branding. Like, there's actually very little WCF in WCF Data Services. They stripped off the whole service model, and I think they just used the channel stack. But it was, at the time, everything that had to do with services had to be branded WCF, so it became WCF Data Services. WCF RIA Services is a really convenient way where you want to build, in particular, like a line of business application, and you're using Silverlight, and you need some sort of back-end for doing that. So this is for building Silverlight applications, and it gives you a back-end for those Silverlight applications. And it has a nice model where your business rules and logic get synchronized between the client and the server. So that's what WCF RIA Services is. Who's using that? Who's using WCF RIA? A couple folks. Okay, cool. WCF Web HTTP. Some people call this WCF REST, although I don't think we actually use that branding anywhere. In the MSDN docs, it's actually called WCF Web HTTP. And what this is one of WCF's costumes that it tries to put on to pretend to be a stack for building HTTP services. There was an observation after, we had shipped WCF, we had great WStar support, great SOAP support, and then lots of folks in the industry were starting to build just vanilla HTTP services. And early on, they were called like plain old XML services, RESTful services. They went through lots of different names. And the WCF team observed this and was like, we should have a story for doing this too. And so in .NET 3.5, we shipped a way to build RESTful or HTTP services using WCF to just deal with vanilla HTTP requests and response. All right, who's using that? Is anyone using WCF? Yeah, okay, a few more in there. Okay, great. ASP.NET Web Services. This is going a little far back here. Back .NET 2 days, .NET 1. ASP.NET Web Services is like the original .NET SOAP stack. ASMX, it was super hot. It's awesome. But yeah, it's a little bit old. Basically superseded by WCF. ASP.NET MVC. On the ASP.NET side, ASP.NET is focused on web apps, right? You're trying to build web pages and so forth. MVC stands for Model View Controller. You use MVC when you want to follow the Model View Controller pattern for creating your web applications. You have some views, usually written in a nice rendering engine like Razor, and you have some controllers, which is basically your logic, and then you have models that you then bind to the views and send back some HTML, handle form posts and those type of things. But also when you're dealing with web apps, you frequently want to do things client-side, where you want to just make requests to the back end and pull down some data and then manipulate the client-side DOM. They often call this AJAX. And MVC recognized that there was a lot of people who wanted to do this, and so they created a very simple way from within an MVC controller to return some JSON. They have this JSON result concept. And it was really, really simple. You just return JSON result, you got some JSON, really easy to consume from a browser. Didn't have nearly as many features as, say, like WCF Web HTTP did, but it was just really easy. And WCF had a sort of a reputation as being harder, and so a lot of people built their web APIs or their HTTP services using MVC. New kid on the block, ASP.NET Web API is a new framework that was specifically designed for building HTTP services. It is the most recent turn of the crank of Microsoft's attempt to build a great framework for building HTTP services. And we'll talk a lot more about that, in part because I own it. ASP.NET Web API also has support for OData. We ship a bunch of components on top of ASP.NET Web API that let you also build OData services. And it plays really nicely with the Web API model. It gives you a lot of flexibility to have full control over the request. You can bring as much OData to the table as you want. Like if you want to, you can just say, I like the OData query syntax, but I have my own formats. I'm just going to bring in query. Or you can say, I just want to support the format, but I don't want to support all of those OData queries. I'm just going to allow these particular queries. Those type of things. It gives you the components that enables you to do that. And lastly, SignalR, also a new kid on the block. SignalR is a framework for building real-time services for the web. You have a browser that you want to be able to get push notifications from a server, have a duplex channel of communication with the service. You want to do real-time stuff, like have a stock ticker that updates or chat, those type of things. Gaming is a common scenario. And it's not just specific to web browsers at all. The same. They have client-side story also for Windows Store apps, desktop applications, Windows Phone, and so forth. All right. Did I miss any? Is there any other .NET web service frameworks that I forgot to list? Feel free to shout out if I missed one. What was that? Phase what? Page. Go up to the mic. Tell me. Turn the mic. You got the mic right there. Just scream into the mic so I can hear. Static page methods, like IHP handlers? Yeah, sure. I almost put that up as a joke, but actually it's true. It's true that I know of people that built their backend, like their backend web APIs, just IHP handler, and that's if you want to write in IL, you can also write in IL. That's great. All right, so I'm going to go with this list. Which one should you pick? What's the right choice for the right scenario? Disclaimer, like I said, I may have some biases here. I work on ASP.NET Web API, shipped an ASP.NET Web API. I kind of think it's really great for a whole lot of stuff. That said, I will also say that if I look at this slide, and I don't know if I should mention this or not, I have had a direct hand in at least half of these frameworks. Like I was on the WCF team from V1 and when it was called Indigo, and I was with it with every single release of WCF. I had a hand on WCF Web API, which was one of the turns of the crank at WCF Web HTTP. I currently own Web API. I currently own MVC. I owned ASP.NET Web Service. So, these all have a fond place in my heart. And I know what you're thinking. No, it's not my fault. Okay? It's not my fault. But that's where I'm coming from, just so you know what my biases are. All right, so here's some of the bitter messages, right? But no one likes to be told that maybe that something that they're using is not something they should be using, but it is what it is. So I figured I'd start off with something easy. Don't use .NET remoting. Like I didn't even put it on the list. You just should not use it. WCF team's been saying this for years, so hopefully this isn't news. WCF basically completely replaced all the .NET remoting scenarios. I think the only case you could use it is for like cross-app domain calls, but you don't even really know you're using .NET remoting in that case. It has tight coupling. It doesn't scale very well. It doesn't interoperate with anything. Don't use .NET remoting. So hopefully that one was easy. Next one's a little bit a little harder, but hopefully also isn't new, as we've had this plastered all over MSDN for a while. Don't use ASP.NET Web Services. That's like the old SOAP stack. Has anyone written an ASP.NET Web Service in the last year? Oh my goodness. That's great. No, that's awesome. Love you guys. You should be using WCF. WCF does everything ASMX could do and a whole lot more. You'll get a lot more mileage out of it. You should be using WCF. Here's one that's probably a little bit more hopefully there weren't a lot of hands raised for RIA, but the current recommendation is, I talked to the RIA team about this. The current recommendation is you shouldn't really use RIA. Like if you want to write a Silverlight app, try to use something like ASP.NET Web API on the back end. Prefer that. RIA is coupled to Silverlight currently. It's coupled to your application, so it's not that great of a service-oriented pattern. It's currently not getting a lot of investment from Microsoft. That said, there are talks about how can we give RIA some future, like there's discussions around can we give RIA to the community, for example, make it open source, let the community own it and love it. Those are still in discussions, nothing to announce there. But currently the recommendation is, at least when I went and talked to the RIA team, is that they're saying prefer writing web APIs over using WCF RIA services currently. I talked to one attendee at the conference where they said, well, I'm just writing a line of business app. It's all internal. I'm just going to use WCF. All I care about is Silverlight and maybe phone and store, and all those things can consume WCF. And yeah, that's true, but imagine a world where you want to actually move away from Silverlight and actually have an HTML5 client, for example. Consuming SOAP from HTML5 just doesn't work. It's not going to give you a good future in that space. But just for fun, don't panic though if you're using any of these things. All those people that raised their hands that I just built ASP.NET Web Services, don't panic. They're all supported, and they all continue to ship. They're all there. They all have the standard 5+5 support policy from Microsoft. So if you're using them, it's not like they're going to disappear. They have not disappeared, and they will continue not to disappear. Just to prove that point, I thought for fun I would do an anti-demo. So I'm going to go over to Visual Studio right now. This is my brand new shiny Visual Studio 2012. All the latest, greatest features. Web APIs in there. It's awesome. It's very gray. But I thought, it was late last night, and I was actually wondering, can I actually create an ASMX service in 2012 Visual Studio anymore? And then, first I did file new project, and I looked, and it doesn't show up in the list, right? So I don't know, but let's create wait, let me give this a name. This is a serious ASMX. This is serious stuff. Okay, so ASMX, what maybe I can add one. Maybe I could do like add new item and do a little search here. I want a web service, right? And lo and behold, there's a serious ASMX service, and boom, and I can run this thing, and it's still there. It's shipped with Visual Studio 2012. That means it reset its 5+5 support policy, and it'll be supported forever. And this thing was sexy, wasn't it? Look at this thing. It's got this button here. You can click this other button here, and you get invoke stuff. It took WCF years to get anywhere near that. Years. We just need to slap some Twitter bootstrap on this page, and it'll look beautiful, and we'll be done. That'll be awesome. All right. What about the consumption side? Can I create an ASMX proxy? Let's do a new project, Windows, console app. There's no add web reference anymore, right? We got rid of add web reference, or did we? Add service reference. If you're an advanced user, right? All those folks who built ASMX services, if you're an advanced user, you click the advanced button. And down hidden here, there it is. Services in my solution. There's my service. Let's give it a name. Web reference, whatever. I don't know why this button is here and not down here. I keep clicking this cancel button over and over again every time I practice this demo. But there it is. Let's set this as my, where's the set as startup project thing? There, set up startup project. Let's see if it's actually, does it work? I think in ASMX you were supposed to call your client a proxy. Wasn't that what it was? Yeah, there's my web reference code that I created. There it is. Yes. Hello? No. Oh, well, yeah. No. I thought you were saying no. I was like, what do you mean no? Please don't say no. Let's write this puppy out. And let's Control F5. Is that going to work? Hello world! ASMX, it's still there. It works. Anyway, you get my point. Like, it's still, all this stuff is supported forever. Like, as forever as anything can be. It's shipped and shipped and shipped despite our guidance to tell you, please, please don't use it. But don't do that at home. All those people, shame on you. Use WCF. All right, so hopefully we got rid of some options. No ASMX. RIA, hopefully we'll have some future going, but right now the guidance is don't use RIA. What's next? Well, next we need to have the gentlemanly SOAP versus REST discussion. So what is SOAP? SOAP is an XML InfoSet-based messaging protocol. And what it is you have a message, it's got an envelope, it's got some headers, and then a body. And I'm showing you the elements. So that's the envelope element, it has some headers and the body. And it's XML InfoSet, but most of the time when you're doing interop, that XML InfoSet is just XML, text XML. But they can be sent over any transport. That's one of the nice things about SOAP. It's not bound to any one particular transport. The spec defines a binding of SOAP to HTTP. And there have been other specs that define bindings of SOAP to other protocols like UDP. WCF ships a binding of a binary encoding of the XML InfoSet of SOAP to TCP, which is just blazingly fast. You can send lots of messages. It's bidirectional. It's great. But you can use it over any transport. And that was one of the goals of WCF. When you look at WCF, one of the things you realize is WCF was trying really, really hard to create a separation between the transport that you're sending the SOAP messages over and then your service model that you're using to actually create your service. It's trying really, really hard to do that. HTTP for WCF really, honestly, is just another transport. It's just another way of shoveling bits around, as far as it's concerned. On top of SOAP, there was a whole bunch of great and useful protocols that were defined, called the W* suite of protocols, because they all start with WS-something, WS security, WS secure conversation, WS atomic transactions, et cetera, et cetera. And they define things like additional semantics, like security, reliable messaging, transactions, addressing, attachments, and so forth on top of SOAP. And WCF is arguably the best WS* SOAP stack on the planet. Like, I've worked on it for a long time, looked at the other ones, and it's arguably the best. If you're going to do SOAP, WCF, definitely the right answer. Here's some example SOAP messages. I had to crack open my memory archives and remember how to create a WCF service last night, and I opened up Fiddler so I could trace the messages and see what they look like. This is a SOAP request. This is actually SOAP 1.2. You've got, and notice that a couple things to notice about this request. One is it's a post. It's a post request. And here I want to get the stock value for Microsoft. I have a little stock value service. The action that this request is actually doing is really, like, the HTTP verb is irrelevant. The thing that really matters in terms of the functionality you're trying to execute is that SOAP action. You see it in the content type header. See that action equals and then some URI. When you're doing SOAP, you define your own SOAP actions, and they can be anything you want. It's kind of a very RPC-like model. You're basically invoking functions, methods, procedures somewhere over there, and it's this one. And then you got a whole bunch of XML. There's your envelope. There's your body. There's no headers in this particular example. But if I enabled WS addressing, you'd see a big blob of XML for the address of the envelope. It's quite a bit of stuff. Like the only real piece of data in here. Do I have a little trigger thing? Maybe not. If I knew how to do. Oh, there we go. Like, that's really the only interesting piece of data, right? Like, I just want to send you 4 characters so that I know which stock ticker to do. So it's got some overhead. One of the criticisms of SOAP is, like, if you're dealing with a mobile device where power and bandwidth are at a premium, you're on a cellular connection, all that extra goop, seems suboptimal. This is the response. It's 200 OK, and I get my data back again, a lot of goop, and there's the actual data that I wanted back. One thing I mentioned, that these are SOAP 1.2 messages. SOAP 1.2 is the actual standard SOAP spec. Most of what WCF does by default is SOAP 1.1, right? And you have to go in. I had to go in and configure WCF to actually do SOAP 1.2. And it was kind of interesting. To do that, it actually required using a custom binding. You couldn't just use like the standard basic HTTP binding. Like WCF has the channel stacks that are sort of pre-packaged. And one of them, the common one you use is the basic HTTP binding. That uses SOAP 1.1. To use SOAP 1.2, I had to create a custom stack of channels. And I thought I would just show, since this did mention WCF in the title, show at least a little WCF code. And so here's my configuration for my WCF service. One thing to notice is there's no web.config in here actually for this WCF service. And there was actually a lot of work done on WCF, like in 4 and 4.5, to really simplify it, make it easier to use. WCF got a lot of flack for a lot of these, a lot of sharp, pointy things that you cut your fingers on, angle brackets in your web.config. Most WCF services you need no config at all by default. You just run it and it'll stand up endpoints for you. Interesting thing is there's also a code-based way to configure WCF services that's fairly new. You just add a public static void configure method to your WCF service. It takes a service configuration object, and then boom, you can do it all in code. So that you can use the C# editor. Oh, you probably can't see this very well. I made this mistake last time. And people told me, hey, where's the quick launch? Oh, this is up here. Right? Font. And I'm supposed to increase this to like that. There. Can you see in the back now? Yeah, sorry about that. My bad. Okay, so there's a public static void configure method. That's the convention. It takes a service configuration object. And here I'm saying I want to enable this protocol. You give it a binding, and it says that any HTTP-based endpoints use this binding. That's what that's doing. And I'm setting up a SOAP 1.2. I did try addressing, though I didn't put it in the slides. A SOAP 1.2 based binding. So there's a cool little feature, a little trick that you may not have heard much about, code-based config for WCF. Okay, now what is REST? REST is an acronym that stands for Representational State Transfer. And it was coined in a dissertation by a gentleman named Roy Fielding. He was one of the fathers of HTTP. He worked on the HTTP spec. And REST is an architectural style. It's not even architecture. It's not a protocol. It's an architectural style. It's a bunch of principles that it was an attempt to describe the architectural style used by the web, the characteristics of the web. And Mr. Fielding talks about a bunch of constraints that were used in that architectural style. Things should be client-server. Things should be cacheable. It should be a layered system. You optionally can have code on demand. There should be a uniform interface for all of your resources and a whole bunch of extra details on what a uniform interface means. But informally, for laymen, people usually refer to RESTful services or WCF REST. Really what they're saying is not formally what Roy Fielding defined. They're actually just saying some sort of HTTP service that's not using SOAP, honestly. And if you say that and you have someone in the room who really cares deeply about REST, you can see their face turn red and they'll get very flustered. But, it's okay. Like REST, when I say RESTful service for the rest of the talk, what I mean is basically is an HTTP service that's not using SOAP. But you should know that there is a more formal definition for REST, and it defines a whole bunch of interesting and useful principles that have some nice benefits. Achieving scale. If you want to scale like the web, following RESTful architectural principles is a good idea. When I say Web API is actually just another term for an HTTP service. We're just talking about an HTTP service. It doesn't necessarily mean even that the service is resource-oriented. When we talk about Web APIs, it could be fairly RPC-centric. Like you're not just getting and putting and updating and deleting resources. You may have actually something that feels more like you're calling methods. Like you have a calculator HTTP service where you're adding and subtracting. And we're not super opinionated about that, particularly on the ASP.NET Web API team. You can do either, whatever works for your applications. We lean a little more towards the RESTful style. We've worked with a lot of those folks, and there are some good benefits, but you can do either. So that's what we mean by REST. Here's an example of the same stock ticker service written RESTfully. It's hopefully it speaks for itself. Compared to what the SOAP requests look like. Things to notice that the verb is actually a get verb in this case. That means that the HTTP has, you can leverage the well-understood semantics of HTTP for this request. A GET request in HTTP says, it's not going to change anything, it's not going to have any side effects. It's safe to cache. You have the ability to add cache control headers to this thing so that you can cache the response. With a POST request, a POST, which is what pretty much every single SOAP request goes over, A post says, there may be side effects. You don't really know what's going on, so please don't mess with this request because this could be anything, is what a post request says. Using the well-understood semantics of HTTP, you can get more benefits. You can take advantage of the HTTP proxies and middleware that can understand what those verbs mean. That's point one. The data also, you notice, is just a lot more compact. The response type here is application/JSON. It's been really popular. It has a lot less characters that are used to represent the same amount of data, so you get smaller payloads, which is nice. So when you think about SOAP versus REST, I think the key differences you'll see, one is with REST, you will have and I mean REST in the informal sense, you'll have the ability to have broader reach. If your goal is to write an application that's going to be available to browsers, to phones, to tablets, to Windows Store apps, to random pieces of hardware like set-top boxes on your TV, to your car, whatever. One of the things that all those client platforms actually do have in common is they all have an HTTP stack, which is amazing. But they do. They all can speak HTTP. One thing they can't do really well is speak SOAP. They don't all have a great SOAP stack. I was messing around a little bit. I don't write iOS and Android apps, but how to call a SOAP service from iOS. I'm just trying to see, how do you do this? So here's a Stack Overflow answer. Let's see what this guy says. I'm trying to write an iPad app. I want to call a SOAP web service. What are you trying to call? You're trying to call a REST-based service or a SOAP service? Sorry, it's SOAP. I'm not familiar with REST. And they're like, basically, well, use REST. Oh, okay, well, that's not very helpful. There's this thing here. This is like, okay, there's some code here, like some generated stuff. And then down here at the bottom, it says to try your free trial, click here. So you can buy something. You can go buy something to consume SOAP services. What about this one? Bunch of code. I see an HTTP request that looks promising. SOAP is over HTTP. Oh, you can string concatenate your way to victory with lots of pointing anger brackets. You get my point. Like it's if you're going to try and consume SOAP from any of these other devices, Microsoft we do pretty good. Like Windows Phone, Windows Store, we did Silverlight. We did a lot of work to make sure WCF's client story was available there. There are limitations on each of those platforms, but it is there. You can send and receive SOAP messages. But if you go beyond that, like certainly browsers, no way. Like iOS, Android, it's going to be hard. You'll get broader reach if you use a more HTTP service style pattern. And hopefully with all those clients, you're going to want to scale. You're going to want to be able to handle them all. And we know that a RESTful style can scale really well because it's basically the architectural style of the web. I think there's also just a desire with a lot of people to keep things simple. Like, do you really need that extra layer of protocol? Do you really need that extra layer of abstraction? Can we get there's a lot of options. Even though we've tried to hide all the config in WCF, there's still a lot of knobs there if you really look for them. Can we get away from a lot of that ceremony and simplify? How can we keep things simple? That's why building HTTP services is generally a great idea, and the ASP.NET Web API being the framework that we've built to make that really easy to do. Okay. Now, in any SOAP versus REST discussion, inevitably someone asks, well, what about security? How do you do security? SOAP has a lot of maturity, actually, in the security space. There are some really, really thick specs that describe how to do message-based security with SOAP, that was security, that's secure conversation, and all those things are implemented in WCF, and you can go and pay some really nice consultants to help you configure those things. But what about REST? What if you want to do security with an HTTP service? How can you do that? Well, the cop-out answer, of course, is, well, it's just HTTP. You just use the standard HTTP security mechanisms, which do exist. You can use SSL for encryption. You can, for authentication, there's a standard way of doing authentication in HTTP. You make a request, the server challenges and says, you're not authorized, but here's how you can authenticate. And you have a choice of doing one of various standard HTTP authentication protocols. You can send your username and password, digest, Microsoft has NTLM, there's Kerberos, and so forth. But if we were really fair, when you start talking about HTTP services, things that you're trying to expose as a services layer, so a lot of those HTTP security mechanisms break down. They're not great. Like, you don't want to be sending your credentials on the wire with every request. So what can we do there? The truth is that I don't have a ready-made answer that I can give you that you can just go start trying it out at home and building fully supported secure web APIs. But it is something that we're actively working on. And so I thought I would just give you a quick preview of some of the things that we're doing around security and web APIs. So I have a project solution here with these are a bunch of preview bits. Most of the preview bits are actually public in our various Coplex sites because they're open source. We've been trying very hard on the ASP.NET team for our new frameworks that they're open source. You can look at the code. You can see the check-ins. But I have basically 3 projects in this application. One is a SPA. SPA stands for Single Page Application. It's basically a browser client for web APIs. So it has some HTML and some JavaScript that's going to call some web APIs, pull down some JSON data, and update a UI. Okay? And this happens to be a to-do application. Then I also have a Windows Phone and a Windows Store application that are using those same web APIs to have a similar experience within those devices, like a native Windows Phone to-do application and native Windows Store application. Okay? Now, I went ahead and I published the the SPA application to Azure. And so let's go ahead and look at it. I did that for a couple reasons. One is that the phone emulator doesn't like localhost very much, the Phone 8 emulator. And also there's some security features in Windows Store that doesn't like localhost very much either. So this made my life a little bit easier. There are other tricks around that, but this was a simple solution because it's really easy to publish to Azure. Okay, I'm going to log in. This is all SPA, so everything you're going to see here is actually happening in the browser. Like the browser is making AJAX requests to the web API. Like if I F12, start capturing, Control F5 again, what just happened there. Down here at the bottom, you'll actually see there's just a normal web API request, API/to-do list. And here it's actually an OData service, so it's using some new OData feature support in web API $expand to pull down the to-do list with the to-dos in them. And if we look at the response body, there's all the data. So that's just a web API call. And it's secure. So I used the username and password, was able to call the web API. And the way it's secured is using OAuth 2. I don't have time to do a full overview of what OAuth 2 is. But basically, OAuth 2 is an authorization protocol where it provides a way, a framework. It's not actually a protocol per se because it's a little bit underspecified to be a protocol. It's actually called a framework. But it's a framework for allowing you to do things like you have a client application that wants to access some resources that are owned by a user. And it wants to be able to get authorization from that user to access that user's resources. And those resources in an OAuth 2 world are really just web APIs. The client app wants to make some HTTP calls, get the user's resources, but it needs permission to do that. And OAuth 2 describes how you can redirect the user's user agent, like their browser, to an authorization server component that can ask the user, first authenticate the user, who are you? And then ask the user, well, is it okay if this client app accesses your stuff? This is what it wants to access. And the user can say yes, no. If they say yes, then the authorization server can then bounce the browser back to the client and give the client something that it can use to get an access token, a token that it can use to then call the web API. And there's a spec also that specifies how you can pass that access token in a standard authorization header used by HTTP. It's called the OAuth 2 bearer token specification. That's what we're using in this app. If I look at the app, there's this startup.auth file, which has all the authentication configuration for this app. You'll see there's this app.use OAuth bearer authentication piece of configuration. It's a piece of middleware that sits in front of the web API and looks for those bearer tokens coming in on the request. If there's a valid bearer token, it says, yep, this client was given permission to access this resource. If there's not a bearer token that's valid and present, it says, sorry, unauthorized. Try again. Go get a token someplace. Okay? And this also has some configuration for enabling authenticating the user using Facebook and Google, because the app needs to have that little authorization server piece. That's something where the client can get the token from. And that authorization server piece needs to know who the user is. And so you need ways to do that. And this app uses username and password, but also supports Facebook credentials and Google credentials, and actually even an Azure Active Directory user can log in with this app. Okay? So, if I look at my user, you'll notice I've actually associated with this user a couple of other identities, one for Facebook, one from Azure. I didn't do Google, but that's okay. All right. So if I do now go to my Windows Phone emulator here, zip down here to the bottom, I wrote a little Windows Phone app. In here, I can make sure this is going to work. Okay, great. Now I need to encrypt my password. And you notice it's pulling down exactly the same data. And what this Windows Phone app is doing is it has the username and password in this case. It's going to that authorization server and saying, hey, the user gave me permission to access their stuff. To prove it, here's their credentials. And it gives it a token. And from that point on, the app doesn't need to concern itself with trying to remember what the username and password of the user is. It can just use that token to access the service. If we go back, I think back works. I don't know. This app is a bit, this is all prototype code. I also have an option of saying, oh no, I'm going to authenticate the user using Facebook. Let's see if this is going to work for me. Oh, I'm already logged in with Facebook. Let me go back. I don't think I logged in with Azure on this one. Am I logged in with Azure? Okay. So here, I'm going to set it, the app is saying, I want to authenticate, the user has clicked a button and said, I want to authenticate using Azure Active Directory, which is a new cloud directory service offering in Azure. And so what the phone app is doing is it's basically popping up a browser control. And it's pointing it at a URL that it got from the web app. It went to the web app originally and asked it, hey, what external authentication providers do you support? And it pulled down a couple URLs. Those buttons at the bottom were populated based off of that call. And it got those URLs back from the web API. And then when the user clicked the button, I want to do Azure, it then points the browser at that URL, which initially goes back to the web app with a little query parameter that says the user wants to authenticate using Azure. And the web app says, OK. And it bounces the browser over to Azure's login page. So I can log in here. The cool thing about the fact that this is that Azure Active Directory offering is that you can synchronize Azure Active Directory with your on-premise AD. And so technically, you could use that to log in using a corporate credential. And this is just all HTTP, so you could do that from any device, even like an iOS device or an Android device. So to give you an idea of what's coming, that's what's things that we're thinking about. I didn't do that here, but let me do test. This is my. This is a user that's actually just in the directory. It's not synchronized with any on-premise AD. And then let me make sure I'm typing. Let me encrypt again.
Yeah, can I ask a question?
ASP.NET. 1 second. ASP.NET auth test. Oh, crazy stuff happening. Oh, I don't know what's happening. Like crazy stuff's happening in the web app. Let me go to the Windows Store app. I'm going to leave this one because I don't know what's going on with it. Like I said, this is prototype code. This is early stuff. But I can do the same thing. And I heard your question. Just give me a second. I'm going to do the same thing this is a Windows Store app. Again, you saw how those buttons loaded a little bit delayed. It's because it's pulling down the URIs for the external authentication providers first. If I click on one of these, I'm going to click on Azure. And here, instead of popping up a browser control, it's popping up the Windows Store has this nice feature. It's called the Web Authentication Broker, which is basically a browser control, but it's isolated from the app. When you just pop up a browser control on a phone app, the app can still reach in and mess around and actually see your credentials. It's still a good thing for it to do because it gets out of the business of handling the user's username and password. But in this case, with Windows Store, you actually have a component that's isolated from the app. The app can't see what I'm doing in here at all. Let me try this again. ASP.NET auth test on Microsoft.com. Sign in. And there's the same data. Okay? So that gives you a feel. The security for RESTful services, yes, it's a little earlier, not as mature as, say, the WSTAR space for SOAP, but it's coming. We're working on it. We're going to give you great framework support. There are frameworks and protocols out there that you can look at and use today if you're willing to write some more code, and we will give you better support for it as well out of the box. Now, there was a question. I'll take that one question. So the question was, what's the benefit of using that token, that access token that the app got, versus just, you got the user's credentials, why not just, pass those? The benefit is that it's more secure. Like, instead of every single request having, like if you're using basic auth, every single request would go with the username and password in the request, and the app has to remember what your username and password is. If you use an access token, and by the way, now that the app has your credentials, it has everything. It has your whole, it can do anything it wants as you, because it actually has your credentials. With an access token, it can potentially have only limited access to the things that the user allowed it to get access to. Like maybe you only gave it access to, this one piece of resource, not your whole Facebook account, but just this one piece of data from your Facebook account. Those access tokens can be short-lived, and they can be refreshed. But when the client app goes back again and refreshed, they could be revoked. Like the user may have gone in and told the authorization server, that client that I told it was okay to access my stuff, no longer okay. Revoke its access token, and then the client won't be able to do that anymore. So you get out of the business of the client no longer has to worry about managing username and passwords and worrying about, did I just lose the username and password? That liability. It's more secure. The credentials it's getting is more scope to what it's trying to do. They can be short-lived. They can be refreshed. There's a bunch of nice benefits there. I mean, if you ever gone to an app store and downloaded an app and it asked you, please give me your Facebook credentials? Like, doesn't that make you a little nervous? Like, hold on, I don't want to give you access to my whole Facebook account. I just want to, maybe I'll let you look at my, something, a couple of my friends or something. I don't want to give you my Facebook credentials. These type of patterns are designed to allow you to get out of that world where you're giving your credentials over to any app that you may not even trust. All right, got to move on. Okay, so here's a high-level comparison, SOAP versus REST. SOAP is great for legacy interop. Like if you need to interoperate with a SOAP service, well, you got to use SOAP. It has established security practices. It works over multiple transports. It's not just HTTP. You can use TCP. You can use UDP. You can use MSCP. Use whatever. It does have a bunch of tooling around generating clients. Like there's all these custom SOAP actions. How do you call those SOAP operations? Well, good news is that SOAP services have a lot of metadata. They have these WSDL documents and schemas that you can run through a tool and it'll generate code for you. A lot of people like that. It means that you get like a nice IntelliSense and object-oriented like programming model for calling the service. But they do tend to come with a degree of complexity, a degree of overhead in terms of the wire format. They don't have nearly as much reach in terms of how many clients can consume them. On the RESTful side, you get great client reach. You can hit browsers, mobile devices, you can hit anything that can speak HTTP. It does have emerging security practices. They're not all there yet, and we're working on our own framework support for them, but they are coming. You can support multiple formats. Unlike SOAP, where SOAP you could do multiple transports, well, with RESTful services, you can put whatever you want in that HTTP request or response. It could be JSON, it could be XML, it could be binary, it could be PDFs, it could be whatever media type you dream up. With SOAP, the format is these guys, angle brackets. And if you want to do anything else, then you have to invoke some WS attachment something or other in order to attach additional data to your SOAP requests. RESTful services are following the uniform interface principle of REST, which means that you don't actually really need a generated client because you know what the actions are. They're get, put, post, delete if you're dealing with HTTP. They're known actions. There are things that you can do to generate code to help, but for the most part, you can get going pretty easily with just HTTP client and send HTTP requests. You get a lot more. It's just simpler. There's less in the stack. There's less going on. So that's the overall comparison. In general, if you're dealing with front-end services where you care about reach and you're using HTTP, it's for the web. These are web-facing services. You should use RESTful services. You should not use SOAP. I wouldn't recommend using SOAP at all for that scenario. Now, that doesn't mean WCF is dead. This is a scene from a Monty Python movie where this guy is walking around collecting dead bodies from some village, and this guy brings out some old senior gentleman who claiming that he's dead, but he's not actually dead yet. I'm not dead yet. There's still good reasons to use classic WCF. If SOAP interoperability is a requirement, you've got to use WCF, of course. It's the best SOAP stack on the planet. If you need to work with other transports other than HTTP, WCF is what you should use. Like, how are you going to do multicast from over HTTP. Like you could set up a whole bunch of connections, but why not just use UDP for that? If you have a back-end service and you don't care about reach at all, you just want a pipe that's as blazingly fast as you can make it, the NetTCP binding in WCF is a really good option there. It's tough to beat. And if you need the WS-based security options, then you'll have to use WCF for those things as well. But other security options, I think, are coming. I think you'll be happy with them. All right. So classic WCF, okay for SOAP, but for front-facing services, recommend using REST. So what should you use to build your RESTful services? There are options there. WCF has WCF Web HTTP, and I saw a bunch of hands of people saying they were using it. A bunch of people have used it. WCF's been trying for a while to re-skin itself so that you could use it to create HTTP services. I think WCF Web HTTP first shipped back in 2007 or something like that, and it shipped in .NET 3.5, and had some issues, and so they went out of band with this thing called the WCF REST Starter Kit, which had a bunch of new cool ideas. It was, I think, the first rendition of the new HTTP client that shipped in .NET 4.5. And a lot of those ideas made their way back into the .NET framework in .NET 4, in the next turn of the crank for WCF Web HTTP. But there were still problems. There were still things that people weren't happy with. And so we went out of band again. We created this thing called WCF Web API, which was an out-of-band effort to try and make WCF work even better as an HTTP service platform. And there were some good things that were done over those many, many years of previews and releases. But at its core, the problem with that approach is that, like I said before, WCF is a SOAP stack. If you look at system.servicemodel.channels.message, which is the core message abstraction in WCF, what you will see is something that has, yes, it has headers and a body, and they are all based off of an XML reader or an XML writer. It's fundamentally a SOAP message, and any attempt to do HTTP services on top of WCF was really trying to swim upriver. Now, on the other side of the house, in ASP.NET, you had an ASP.NET MVC. People were building simple little HTTP services that could serve up some JSON using MVC. They were very happy. They liked the simplicity. There were a lot of cool features in WCF Web API, like some early attempts at supporting content negotiation, where the clients can ask for the format that they want in the HTTP response. Nice pipeline features. A lot of work to try and give you better access to the HTTP concepts. WCF is trying to treat every transport the same, and it's trying to abstract it away. So getting at those concepts of I want to deal with some headers. I want to deal with the status code was hard, and so there was a lot of work that was done to try and make that easier. ASP.NET MVC, less feature-rich, but arguably simpler. And then what happened was a reorg. That's what happened. The ASP.NET team and the WCF team got put in the same team, and we're still in the same team. Actually, we all work together, and we all looked at each other and said, this is kind of silly. We have these two frameworks for doing basically the same thing. Why don't we take the best from both worlds and build one thing that would be a great platform for building HTTP services? So that was the idea, and that's where ASP.NET Web API came from. It was built from the ground up to be a framework for building HTTP services. And it has a whole bunch of great features that I won't have time to go through all these features in this talk, but I'll just highlight a few. First and foremost, it gives you a first-class, beautiful HTTP programming model. And it's the same HTTP programming model that was introduced in .NET 4.5 with the new HTTP client. If you're familiar with client-side HTTP programming, there's HTTP web request, which has been around forever, like from the dawn of time. In 4.5, we shipped a new HTTP client called HTTP client. And it has this lovely, strongly typed representation for an HTTP request message, HTTP response message. It's fully async. It uses the new task-based async model. It's really a delight to use. And I remember, when I first came to Microsoft, I owned the System.NET APIs, like the old HTTP web request code. And I was new it was when I first came to Microsoft. I was fresh out of college, and I remember soon thereafter I was asked to work on ASMX, and that's when I first learned about the HTTP programming model server side in ASP.NET. HTTP request, HTTP response, the hang off of HTTP context. And I looked at those two things, and I remember thinking, actually I went to my boss. I was like, isn't this wrong? We have HTTP web requests, and then there's HTTP requests. Why do we have two of these things? Shouldn't there just be one? And my boss, spun my head around a few times. Said, no, there's good reasons. Like, we need to do this. And it turns out it was all lies. It was just dirty, rotten lies. There's no reason to do that. And in Web API, we've actually taken that same programming model, HTTP request message, HTTP response message, and a nice, simple message handling pipeline, and we use it both client-side and server-side. And you can run the whole pipeline, even in memory. You can new up an HTTP client. You can plug in a little message handler that just pipes the messages directly to an HTTP server, right to your Web API, and get the requests back. You can do full integration testing in memory. It's gorgeous. I just can't say enough. If you want to deal with set a status code, set a header, it's right there. It's at your fingertips, and that's deliberate. Because when you're building HTTP services, that's what you want. And then it has a whole bunch of other really cool features. It's really easy to create your resources and create a nice URI space. You can use ASP.NET routing to do that. It's easy to create links. We have help page generation. But one key thing is that the whole framework was designed to be lightweight, to be easy to test. We have some nice testability improvements actually coming in our next version. And it needed to scale. Like the whole thing uses task-based async up and down. So it's pretty cool. One of the features that the WCF Web HTTP crowd often sometimes feels a lack of when they use Web API, though, is they miss the attributes. Like some of them really liked having a class with attributes that you could put on your methods and say, here's the URI template for this method. With Web API, we went with a more resource-centric approach where each class represented just one resource, not many. So in our next version, though, we are doing some work to make that better. Let me show you a preview of a new feature in ASP.NET Web API. And this is called attribute routing. Normally with Web API, now, do I have an attribute route, a normal route in here? Maybe I can just show you. No, I don't even actually have any normal routes in this Web API code. Instead, I just have this one method that says enable HTTP attribute routes. Okay? And what this is this is actually it was a community contribution, because Web API is open source, from a guy named Tim McCall, who started this project that's called attributerouting.net. And he originally did it for MVC, because MVC uses routing all over the place. And it was a way to define your MVC routes using attributes right on your controller methods. And he went and did some work to also make it work with ASP.NET Web API. And we looked at it and we were like, that looks really good. Maybe we can use that too. Would you like to contribute it to core ASP.NET, to core ASP.NET Web API? And Tim said, yeah, sure. And we worked with him, and we worked on the code, and now it's part of the core runtime, and you can try it out in our nightly builds. So let me show you some examples. So here's a Web API. It's a Web API controller. Here are my methods. This is going to respond to GET requests, and this one's going to respond to POST requests. But now I can attribute things to define my URI space instead of doing it all imperatively in code. I can say, here's a route prefix for this whole Web API. Everything in here is prefixed with orders. And here is a resource that I can get, and it's at order/ID, basically. And here's another one that I can approve an order by going to order/ID/approve. Okay? So if I pop up everyone's favorite HTTP tool, which is Fiddler, and run this, I'm going to grab the URI, orders 1, execute. So there I hit that first action. That's great. And it's going to return me an order with that right order ID. Let's check it out. Lo and behold, order 1. That looks good. Now let me say orders1/approve. Now this is a post request, so I need to change this to be post. And it needs to have a content length, so I think that's the right header. So then it hits the approve action. So this is all being done through attribute-based routing. Okay, so that's pretty simple. That's pretty cool. I can use prefixes. I can define routes now right on my my action methods. Let's look at some other scenarios. Here's a versioning scenario where I'm using that route prefix to say, here's v1 of my Web API, and it uses this customer type where the customer ID was an integer. And then I realized, it's not good enough. I actually need a customer type where the ID is going to be a GUID, and so I need to version my service. So here's v1 and v2 of the same Web API. So API v1 customers, API v2 customers. API. Oh, I did a post instead of a get. Those are get actions. There it is. There's I hit the V1. So V1 is an integer ID. You see that? And if I do V2, there I hit the breakpoint for V2. F5. And I'm now getting a GUID instead of the ID. So I just versioned my service. So that's kind of nice. Here's another scenario where often with web APIs, people want to be able to do resources, but they're nested. Like I've got movies, I've got actors, I've got directors, but then I want to be able to say, here's all the movies for this director, stuff like that. Here's some attribute routes. Here's a movies resource. Here's an actors resource, but I can ask it for all of its movies. For that particular actor, here's a director's resource that I can ask it for all of its movies. So if I go back into the composer, I can say, give me all the movies. There, I hit that action. And I get a response that says, title all movies. I can say, actors 1, I want to know what all the movies that actor 1 is in. Execute that, and it hits that second action. 5. Movies with actor 1. All right, and then last one, directors. 1 movies. Execute that, and it hits the third action. Okay, so that's pretty cool. So I can do resource hierarchies using attribute routing. And the last one, and this is where I think we really blow WCF Web HTTP's attribute routing URI template thing out of the water, is you can define constraints right in the route variables. So this case, what I'm saying is I have a people resource, and I can get a person by its ID, and the ID is an integer in this case. So if that segment happens to be an integer, go here. But I can also get the person by their name. And so if that person is not an integer, it's just a string, then go here. So if I say people 1, 2, 3, 4, that goes to the first action because it met the constraint. If instead I say, and if I look at the results, I should see a person with an ID 1, 2, 3, 4. I didn't bother to define a name. And then if I say, Dan, I want to get Dan, it's not going to hit that first action because it's not an integer, it hits the second action. And actually if we look at the attribute routing docs, we just follow, where is it? Here, route constraints. There's a whole bunch of these route constraints that you can just use. And so there's, floats, doubles, simple types. There's even regex, like if you want to define a regular expression so that this action method is only hit if the segment matches a particular regular expression. You can define default values inside the template. It's a very rich syntax now for those routes. So that's a new feature that's coming. Hopefully fits maybe the last feature gap between Web API and WCF Web HTTP. Okay, so the guidance there is there shouldn't be any scenario going forward where you would want to use WCF Web HTTP instead of ASP.NET Web API. I prefer ASP.NET Web API over WCF HTTP in all cases. So I recommend against using WCF Web HTTP. And MVC has very few features. Like for very simple stuff, you can use it. But going forward, if you're building a Web API, if you feel like you want to return a JSON result, you're probably going to be better off just using ASP.NET Web API for those scenarios. All right. So that's the REST versus SOAP. What about OData or no data? Like, should you use OData or not? OData is an open web protocol for querying and manipulating data. And my take on OData is it's kind of on this continuum. Like if you just do a vanilla OData service, it really just looks like a vanilla web API service, particularly with the work they did in the latest versions of the spec. I think earlier versions of OData, I remember I looked at OData and I looked at the JSON that it produced, and it kind of looked like someone had vomited on it. It had all this stuff on it and all these metadata tags. But they did a lot of great work in OData v3, OData v4 to create a new OData JSON format, which is very streamlined. You can get rid of all of that metadata stuff. You can still ask for it if you need it. And there are good reasons why that metadata is there when you might want it. Like you want links to navigations and so forth. But it's very, it can be very clean, like just a web API. And then it adds a spectrum of features that solve a bunch of common problems for web API development that I think a lot of people would find very, very useful, like relationships. Often you have data, sure, but data often is related to other data. That like I have customers which have orders, and orders have line items. I have to-do lists, and to-do lists have to-dos. The standard approach with WCF and serializers is that when you get an object graph like that, is the serializer is greedy. It just traverses the properties and goes and sucks it all down and serializes all of it. And if that type was actually tied to a database, you may have accidentally serialized your entire database, and that can be bad. Whereas OData was designed with that problem in mind. And instead of serializing the whole graph, instead it uses this notion of hypermedia, where you can provide links to other related resources. They're called navigation properties. And then you can say, I would like this to-do list, and I just want the to-do list. And give me the links. Give me some metadata that tells me where to find the actual to-dos. But I just want the to-do list, or I just want to update that to-do list. Actually, now give me the to-do list, but also expand the to-dos. I want it all at once. That ability to navigate navigations, manipulate navigations, I think is a useful concept, something that I know in the WCF land we heard about a lot, and OData solves that problem. Query, often you have a whole bunch of data, 100,000, maybe you're a very busy person, you have 100,000 to-dos, or 100,000 orders, or whatever, and you want to be able to query over that data set, filter to just a particular set of customers, order them, just to get the top few, page through them. How do you could define a bunch of your own query parameters in the URI to accomplish those scenarios. But why? Why not use what is already an open and standard way of querying that a variety of clients already understand how to do? Paging, when you're paging through a big set of data like that, often you don't want to give the client all 100,000 items. You just want to give them a few, and then maybe you give them a link, and you tell them, if you want more, here's where the next batch are. And by the way, here's also another little piece of metadata that says there are actually this many in the set. So if you want to present some arrows with 1, 2, 3, 4, 5 in between so that you can page through them and you know how big the set is, well, I can tell you. You could roll that yourself. You could define your own custom format for those things, but why? Why not use an existing open and standardized protocol? Because OData, by the way, is going through OASIS, and V4 is now out for public review as a standard. Actions are, a pattern where you want to inform the client that, here's a movie, and you can do these things to this movie. You can check it out, you can return it, you can purchase it, and those actions can actually appear right there at runtime as links that the client can use. OData defines metadata for those actions so you can know how to actually execute them. Batching is you want to be able to take a whole bunch of requests, and instead of doing, update that to do, update that to do, update that to do, which would be very chatty, I'd actually like to batch all those requests into one and do them as one request. And that can save on bandwidth, that can save on battery life on a mobile device, where doing all those chatty requests might be problematic. So I think these are common problems. I think they are. Feel free to come up afterwards and tell me if you're like, no one actually needs to do any of those things. But I think they're actually really common, and OData provides a really an open and standard way of doing them. Now, I think OData gets some flack, some criticism for perhaps trying to do too much. It defines this rich query syntax, very elaborate query syntax. Do I really want to expose all of that from my service? Well, the good news there is that we give you components when you're implementing your OData service. You can just bring as much to the table as you want. If you only want to support a specific set of queries, then just support that specific set of queries. And in fact, we recommend that. You probably shouldn't flip the big red switch and allow completely arbitrary queries on top of your database. Your DB admin might be grumpy about that. And we give you the ability to do that. So OData is cool. I think when you're doing REST, OData is a RESTful protocol, RESTful format. It has a lot of useful features. If you're going to implement it, what should you use to implement it? And here is where the guidance gets, I admit, it's not as clear-cut as we would like it to be. There's two frameworks for implementing OData services today. There's WCF Data Services, which was the premier OData stack. It's what introduced OData. And then there's ASP.NET Web API OData support, which is newer. So which one should you use? WCF Data Services' bread and butter is that you have a SQL backend, a full iQueryable implementation, and you just want to expose the data using an open web protocol. That's what it just does beautifully, and it has very complete OData support, the most complete OData support that I think you'll find. Where it doesn't shine as much is where your data source is not actually a database, and you don't necessarily have a full iQueryable implementation to run the queries that are being in the request from the client. If you're dealing with custom data sources, you can do it with WCF data services, but it involves implementing a whole bunch of interfaces that are fairly involved. With Web API OData, you have the full context of the request, and interacting with custom data sources is actually a lot easier. The second place I think I would prefer Web API over WCF data services is that whole idea of constraining, bringing as much query to the table as you want to support. It's much easier to do with ASP.NET Web API OData. And lastly is this notion of custom business logic. With WCF data services, the model is interceptors. You get to intercept the request as it's flowing by, and then you can try and influence things so that when the framework sends the response back, hopefully it does what you wanted it to do. With Web API, you have the full context of the request, so you know what's going on, and you have the full control over what the response is. So it's easier to implement lots of business logic. The trade-off you get with Web API OData is it's newer. It doesn't currently have as many of the OData features implemented yet. We shipped a first version in Visual Studio 2012 Update 2, and that had support for the OData formats, the new JSON Lite. For query, it supported top, skip, order by, and filter. But but more is coming. We're actually quickly filling in the gaps in the OData features in the ASP.NET Web API OData. Like we have preview bits that we're working on for $select and $expand, for $batch. And I think that gap in terms of, but Web API doesn't support the OData feature I need is just going to continue to get smaller and even be surpassed. So I don't think that'll be a concern much going forward. And another gap is that Web API OData doesn't support untyped data. You have to have CLR classes for your data. Doesn't mean they have to be your entity framework types, but there has to be a class there. If you have data that you want to deal with it in an untyped way, that's not there yet. But it's coming. It's all coming. So I think what you'll see is that with Web API today, you get increased flexibility, more flexibility than you have with WCF data services. There may be cases where you'll need WCF data services because you don't have the OData features you need yet in Web API, but that will change over time. More and more features will be added to Web API, and that will become less and less of an issue. Well, I got 7 minutes, so I can do a quick OData demo just so you can see what those new features are. All right. So here is bits that have already shipped. This is actually a public sample that you can go play around with. This is a page that's calling a backend Web API OData service. And if I run this query, it's going to pull down all of the movies from a movie database. And there it's giving me, notice it's giving me them 10 at a time, and I can page through them. If I look at the wire, what's actually going on there, this is where OData is really shining. If I trace that request, 200 OK, and I look at the response body, there's those 10 movies, and I'm getting this nice next link down here at the bottom. You see that? Where in the OData format, it tells you, and by the way, here's the next chunk of data. I can also say things like $inline count equals all pages. And this is instructing the service, please also tell me how many there are total. Oh, with an S. All pages. There. So now I can see how many pages I've got, 1 of 324 and so forth. And that means that if I look at those requests, there should be an extra piece of data, which is this OData.count, which is telling me there's actually 3,407 items in this database. So those are format and protocol features that OData just gives you. For queries that we support out of the box, I can say I would like the top 3. I can say skip the top 3 and just give me the rest of them. I can say order by genre, for example. They're ordered by genre. I can say first order by genre, then order by release year. Now these are just queries that work just solely from the fact that I'm using OData. I can also do a filter. $filter equals, let's say genre equals comedy. So I just want the comedies, and there I'm just seeing the comedies. Okay? To enable that in my Web API, all I had to do was add this line of code. There's my action that's returning the movies, from the database as an iQueryable, and then I applied this queryable attribute to the action method, and that enabled support for OData queries. This page size is saying, only give them out 10 at a time, and add next links, add support for inline count. Okay? Now, that's great. What about, I want to control the queries. I don't want to do all those queries. You can do that too. Allow order by properties equals, let's say I'm only going to allow you to order by genre. So there's all sorts of validation features in Web API. We have some default set of validator semantics that you can use, but there's also a method where you can say, let me look at the query. I can do like pattern matching on the query or parse it and see what's there and decide whether or not that query is okay or not. And that's how you can scope the query space to just a set of things that you want to support. So I build this and rerun it. So now I should only be able to order by, that one property. I shouldn't be able to order by anything else. Let's see. $order by equals genre. That should work, right? Okay, so that order by genre. Now let's see. Let me F12 here just really fast so you can see what happens on the network when I do this. If I say, I'm going to try and order by rating, which is supposedly not supported. Now I'm going to get a 400 response, and that query did not execute. Okay, cool. So that's query validation. Those are all supported features. Those are things you can use today with ASP.NET Web API OData. Let me show you some things that are coming. So here's another service. This is a service that now has preview bits that support select and expand. And let me pop up Chrome here real fast. Okay, so this is a service that has a list of customers. Let's get the list of customers and see what they look like. Wake up database. There they are. Okay, you'll notice that they have an ID and they have a name. But if I use select, what select says is, I want the data, but I don't want all the properties. Like maybe your entity has tons of properties, like 100. I just want these 3 properties on it. And you can really cut down on bandwidth usage by doing that. So select just the names. Okay, you see that? I can also say, just for this individual customer, let me get the individual customer first so you can see what it looks like. So there it also has an ID and a name. I can say, just for that individual customer, just select its name, and the ID goes away. All right. I can also do on the customers, I can ask it to expand some of the related data. Like I don't want just the customers. I also want the orders with them. And I get all the orders with them. I can also say I don't want just the orders. I also want the order items in those orders. And that works too. I can also say, and please also select just the name and the order purchase date after expanding all that data, and then it whittles down the data just to those things. So this is select and expand. What did I have to do in code to enable that? If we look at the, the customers controller, that's the model. Here's the customers controller. That's the code right there to enable that. You just add the queryable attribute and it works. Okay, so that's coming preview feature. That's what OData can do for you with ASP.NET Web API OData. Last thing I'm going to talk about real fast is SignalR. SignalR is really easy. If you're doing real-time web, like you want to have apps that work in a browser, and you want to be able to push notifications to the browser like chat, stock tickers, SignalR hands down is the thing you want to use. It uses WebSockets when available. WebSockets is a fairly new standard that allows you to open a full duplex connection over HTTP. Now, not every browser or infrastructure supports it yet. So if you're in that type of environment, SignalR can also fall back to other patterns like forever frame, server-side eventing, polling. It gives you a really nice server-side programming model. It has lots of support for different client platforms, not just browsers. You can also use it from Windows Phone, Windows Store to set up that duplex channel. WCF also technically has support for WebSockets, but it doesn't do any of these other things. So if you're doing real-time web, SignalR is what you're going to want to do, and it's really easy to set up. So file new let me stop debugging. I can do this. File new project. 43 seconds. New web app, and I'm going to use NuGet in the official package source, and I'm going to pull in a SignalR sample, which you can do today. Just go and grab this off of NuGet. NuGet is a package manager that makes it really easy to get stuff into your projects, like assemblies, content. That's going to add a whole bunch of stuff for the sample code. Close that. Build, just to make sure it builds. Great. And then I'm going to go here to the stock ticker and say View in Browser. Okay, F12 out of that. Okay, so there's a little app. Looks like it's going to show me stock tickers, which is good. Here's a Chrome. different browser over here, same app. I'm going to open the market on that side. And there, you'll notice that the other browser started updating. If I close the market, the other browser stops too. If I open the market on the Chrome browser, IE starts updating. So this is real-time web. SignalR is creating WebSocket connections if it can from both these browsers to the same back-end hub, and then it's you have a kind of a full duplex conversation with the service. It can send notifications to you. You can send requests to it. That's SignalR. If you need to do real-time web, that's what you're going to want to use. It works seamlessly side by side with all the other service technologies, so it's not like it's an either-or. You can have request-reply RESTful services sitting right next to your SignalR hubs, and that works great. So in summary, use ASP.Web API for all of your HTTP service needs. You should leverage OData as a standard open solution to common Web API patterns. Currently, the story around OData is a little fuzzier. In some cases, you may need to use WCF data services because it has richer OData support, but I think that's going to change over time. The Web API will fill in those gaps. For WCF, use it for SOAP interop, use it for non-HTTP transports. It's alive and well for those scenarios, and it works great for back-end services. I wouldn't use it for front-end services because you're not going to get the reach. And then, of course, use ASP.NET SignalR for your real-time web scenarios. And that is it. I'm only 2 minutes over. Thank you so much for staying. I'm happy to stick around and debate with you any point.